All right, apologize for that. I have a certain length of time that I have for the video before its Screencastify closes it down. So apparently I went over my 10 minutes. We'll keep going here. So x is greater than 50 divided by 6, which is going to be 8 1/3. So if you type that in, you get 8.3 repeating. So I'll just make it an exact value, 8 1/3. So x has to be greater than 8 1/3. Remember, for a triangle to even exist, we do have to have a certain range of the values, and that is that the two shorter sides of the triangle have to sum to longer than the longest side. So you can't just make any length of a side of a triangle. So there is a range of values, and so we're going to be thinking about this here. So we know x has to be greater than 8 1/3 using that Hinge theorem, but we also have to think realistically how big 6x plus 15, how big this angle could possibly be. So it has to, we can plug in a number here, and it has to be greater than essentially 65. So it's got to be greater than 65, but it also has to be less than 180 degrees because you cannot have a triangle with angles that sum up to more than 180 degrees. You could have like 179 and 1/2 degree and a 1/2 degree. You could have 179.9 and then a 5/100 and a 5/100 together to make up that last tenth. But you could not have it sum up to 180 degrees. So it must be less than 180 degrees. So we also have to consider that. So we're going to solve that here. And use blue again here. So I'm going to subtract 15 from both sides of that particular equation. Inequality. So that leaves us with 165 here. 6x is less than 165. And then dividing by 6, divide by 6, we get x is less than 27.5. Okay, so here's our range of values that we have. And since I've kind of run out of space here, I'm going to write it over on the side or maybe up top here. So 8 1/3 is like the bottom of our range. So it's got to be greater than 8 1/3, but it also has to be less than 27.5. Because if it is 27.5, that means the angle would be 180 degrees, and we cannot have a triangle exist with one angle being 180 degrees. So there is actual range of values, so we have to think logically about it, not just with the Hinge theorem, but also what the upper or lower boundary would have to be on the opposite side. So let's talk about the hinge that we have in this problem here. So notice that this side is congruent to this side, and we also have congruent markings here and here. So the hinge that we're talking about is the 68 degrees, which relates to that opposite side of 47. And then the hinge we have here is the 55 degrees that relates to the 5x plus 2. So if we look at those two, we've got the angles. And so we'll notice the 5x plus 2 here. Let's think about that. So 5x plus 2 is related to this 47 over here. That's the corresponding part of that other triangle. And we know that that 5x plus 2 is across from 55, and the 47 is across from the 68. So we know 5x plus 2 has to be less than 47 because it's across from a smaller angle than the 47. So when we're solving this one, we're going to first think about that piece of it. So solve, and we get 5x is less than 45. And dividing by 5 times what is 45? Of course, we know that is 9. So x is less than 9. Okay, so we know x has to be less than 9. Now let's ask ourselves, does x have to be greater than something? Okay, so we have here is that the 5x plus 2, it's not necessarily that x has to be greater than something, but the 5x plus 2 here, now think about that. This is a side length. Can we have all range of values for side lengths? No. The side length has to be a positive number, Right? So we cannot have 0 for a side length or a negative for a side length. So when we're thinking about solving this algebraically, we do also know that although it has to be less than 9, the 5x plus 2 piece, or the 5x plus 2 has to be less than 47, the 5x plus 2 also has to be greater than 0. Right? So let's solve that for our x. So like I said, we might end up with a negative for the x piece because we're solving this, but we know the entire 5x plus 2 side has to be greater than 0. So in this case, dividing by 5, we do get x has to be greater than negative 2/5, or negative 4/10 if you want to put it as a decimal. In other words, if we substituted in negative 2/5 in for x here, we would get a side length of 0. So it has to be greater than negative 2/5. So let's go up here and say again. So it's got to be greater than negative 2/5, but it also has to be less than 9 as per our Hinge theorem here. So there's a range of values. So the first little inequality that you solve is kind of related to the Hinge theorem. The second inequality you solve is really related to what is, like, logically, what is the biggest possible angle measure, or what is the smallest possible side. So you kind of need to be thinking about that logically. Okay, so let's go to the next side here. Oops, got a little example here again with the Hinge. Notice that this is why we need a little side-side situation here. These triangles do not share the same side lengths here. Notice our two sides are not the same. So one could say, well, this is a 23-degree angle, so this is an 87-degree angle. Well, the side across from the 87 has to be greater than the side across from the 23 because 87 is bigger. Well, no, you can see here that that isn't the case, right? That this side over here is clearly longer than this side here. Take out a ruler and measure it. And the reason why is because these do not share that side-side hinge. That's why we have to have those two congruent sides where the hinge is, because if we don't have those two congruent sides, then that relationship about the opposite side being longer or shorter based on the angle will not hold. So have that example there. I should have referred to that earlier. All right, backside. So at this point, you might want to just do pause the video and do these practice problems and then come back and check. And so I'm just going to put the answers up here. I'm not going to necessarily work through the problems like I did on the front side, but you guys can check it after you are finished with a little bit of the practice. So maybe pause the video and see how you do. Oops, if you're following me here, I did that wrong.